Good day friends. In this lecture we are going to see about a three-phase voltage source inverter operating in 120-degree mode. Three-phase bridge inverter is shown here. The power circuit diagram for both 120-degree mode and 180-degree mode are same. In 120-degree mode, each thyristor will conduct for 120 degrees of a cycle. There are 6 steps in 120-degree mode also. In 120-degree mode of operation, at any point of time, 2 switches will be on. In 180-degree mode, at any point of time, 3 switches are on. Here, there is a sequence followed. The sequence followed is, in the step 1, 6 and 1 thyristors are on, then 1, 2, then 2, 3, 3, 4, 4, 5, 5, 6. The 120-degree mode of operation is explained using this power circuit diagram. Now, at any point of time in 120-degree mode, 2 switches will be in operation. Like in the first step, the switches 6 and 1 are on. Here, every switch will conduct for 120 degrees. For example, if T1 is turned on at 0 degrees, it will conduct for 120 degrees, and then for the next 60 degrees, that is up to 180 degrees, T1 will not conduct, and T4 is turned on at 180 degrees and it will conduct for further 120 degrees, that is from 180 degrees to 300 degrees. This means that 60 degree interval from omega t to 180 omega t 120 to 180 degrees is see as T4 and T1 do not conduct. In the case of 180 degrees mode of operation, T1 will conduct for 180 degrees and immediately T4 will be conducting for the next 180 degrees. But in the case of 120 degree mode of operation, T1 conducts for 120 degrees and for next 60 degrees, T1 and T4 both do not conduct. Then from 180 degrees to 300 degrees, T4 conducts. This is the difference between the 120 degree mode and the 180 degree mode of operation. The steps 1 and 2 are shown here. In the first step, 6 and 1 are on. And after that, 6 is commutated, 1 and 2 are on. Then the next step, 2 and 3 are on. Here, fourth step, 3 and 4 are on. Fifth step, 4 and 5 are on. The sixth step, 5 and 6 are on. So let us see the first step operation here. When 6 and 1 are conducting, then the current flow in the circuit will be from the source through T1. It goes to the point A, then O, then comes to B, then it goes through T6 back to the source. So here the current flow is from source to the load through 2 switches and 2 impedances. So the equivalent circuit of this step is shown here. Starts with plus, goes to a point A, goes through the impedance Z, this is the point O, and it goes through the other impedance which is connected to B, comes back to minus. So this is the equivalent circuit for the step 1. The source voltage is Vs. So the voltage across both the impedances will be Vs by 2 and Vs by 2. So if we similar to 180 degree mode, if you want to know the values of VAO, VBO and VCO, here we know that VAO is Vs by 2, VBO will be minus Vs by 2, VCO will be 0. So for this step, we have known the values for VAO, VBO and VCO. Similarly, for the step 2, again if we derive the equivalent circuit, now the switches 1 and 2 are on. So the current flow will be from plus through 1 through the impedance it reaches point A, then goes to the impedance, then it goes through the point C, then goes to the switch through the switch 2 back to the source. So again the equivalent circuit here is two impedances connected in series. The source voltage is Vs and half of the voltage is available across each phase. So here the value of VAO is Vs by 2 again, and now the impedance here is in the C phase. So VCO will be minus Vs by 2 and there is no phase voltage at the phase B. So VBO is 0. For the next step, when the switches 2 and 3 are closed, again we can derive an equivalent circuit, and for step 4 where 3 and 4 are closed also we can have a equivalent circuit. In this case we see that for every phase for 60 degrees interval we have two impedances connected in series and the value of the voltage in each phase is Vs by 2. We see this in the table. We see that from 0 to 60 degrees the phase voltage is Vs by 2, minus Vs by 2 and 0. So 60 to 120 it is again Vs by 2, 0 and minus Vs by 2 for VAB, VBO and VCO. So here the sequence followed is Vs by 2, Vs by 2, 0, minus Vs by 2, minus Vs by 2, 0. This is the sequence followed, and if we see for A phase it starts at 0 degrees as Vs by 2, for B phase it starts as Vs by 2 at 120 degrees, and for C phase it starts at 240 degrees for as Vs by 2. The line voltages as explained for the 180 degree mode can be derived by subtracting VBO from VAO for getting VAB. So if you want to get VAB, it is VAO minus VBO, which means Vs by 2 minus of Vs by 2, which is Vs. Similarly, for getting VBC, we have to subtract VCO from VBO. So it is minus Vs by 2 minus 0 minus Vs by 2. In a similar fashion, we can get VCA as VCO minus VAO. So this table, when it is drawn in the graphical form, we can see a waveform similar to that in the 180 degrees. Here we have the waveform for VAO, VBO and VCO. So for first 180 degrees, we have a value of Vs by 2 for VAO, and the same pattern continues for VBO and VCO, but for VBO it starts at 120 degrees and follows the pattern. For VCO it starts at 240 degrees and follows the pattern. If the phase and line voltages both are drawn here, we can see that VAO, VBO, VCO as shown in the previous slide is like this, and VAB is obtained by VAO minus VBO. We can get VS here and it follows a particular pattern. Here also we see that VAB starts with VS at 0 degrees. Similarly, VBC starts at Vs at 120 degrees and VCA starts at Vs at 240 degrees. So there is a phase shift of 120 degrees for each phase. Hope this explains the operation of 120 degree mode of operation. Thank you. There are some merits and demerits of 120 degree mode of operation over 180 degree mode. In 180 degree mode, when T1 is turned off, T4 is turned on immediately, and that T4 is present in the same leg as T1. So commutation interval must exist between turning off of T1 and turning on of T4. Otherwise, the DC source will have a direct short circuit through the SCRs T1 and T4, which is avoided in 120 degree mode, because T1 conducts for 120 degrees, off for 60 degrees, then after that only T4 is turned on in 120 degree mode. This difficulty is overcome in 120 degree mode. 120 degree mode of operation is more suitable for balanced resistive loads only. So the analysis of performance of this mode is complicated for a general load circuit. So this explains operation of 120 degree mode of voltage source inverter. Thank you.